My name is Abdul-Lateef, and I'm welcoming all my viewers to Creative Mastery channel. Today, we are going to be looking at set. We are going to be looking at sets. So we have set. So when we say a set, what is a set? Set is a collection of well-defined objects. So set is a collection of well-defined objects, and not any objects at all. Objects that can be arranged in order of sequence or in order of manner. So a real example is our kitchens. When you come to our kitchens, you will see we have our plates arranged in one side. We have our bowls also arranged in another side. We have, let's assume we have the cooking pots. The cooking pots also arranged in a particular side of the kitchen. So when you come to the football field too, we have sets. We might have set A and set B. We also have our substitution. Maybe there are two football teams playing. We have a set A and set B. So let's assume we are having um, Ghana Premier League Asante Kotoko versus Hasselhoff. Asante Kotoko is set A and Hasselhoff is what? Set B. So this is the set because it's a well collection of what? Players. So we say that it is a set. So we can have, if we have A to be equal to, so this is our curly bracket open. So we have 1, 2, 3, 4, 5, 6. So this one we can call it a set because it's a collection of what? Counting numbers. So this is a set of collection of what? Counting numbers. You can also proceed. We can have a set like this, which is apple, orange, banana. So this is also another set. Also a word collection of what? Objects. And the objects are what? Set of what? Fruits. So set of fruits. Set is an interesting topic as far as mathematics is concerned. So hence we need to pay attention so that we can be able to go through this concept successfully. Now let's proceed and look at the various types of set because we have to know how things are arranged. And if they are arranged in this way, then this is the name given to them. If they are arranged in a particular manner too, this is the name given to them. So let's look at the various types of set that we are having. So types of set. So the first one is let's take the first set. First type of set, we can have a finite set. Finite set. So in our local or in our schools, we say that finity. So this is a finite set. And it's a set that has an end, like it end. So if we have 1, 2, 3, 4. This is a finite set because we know its last element or its last member. So its last member is what? Known. Any set that its last member is known, we call it what? A finite set. So a finite set is a set whose last element or member is known. So this is a finite set. Now let's pick another type of set. So infinite set. So the opposite of finite set is what? Infinite set. So infinite set is a type of set whose last element is not known. So if we are having um, whole numbers from 5 to infinity. So this is a whole number. So we want to have whole numbers from 5 to what? Infinity. So we have our whole number, so which is 5, 6, 7, 8, 9, 10, 11, 12. So in sets, these three dotted lines are called ellipses. Ellipses. So, and they are always three. We shouldn't let it exceed three. Even though if it exceeds three, there is no any problem with that. But mathematically, it's supposed to be what? Three. So we call it ellipses. So this is an infinite set, telling us that the sets of numbers, the final number or the final member or element is not known in this particular set. So this is an infinite set. So a whole numbers, counting numbers, even numbers is infinite, depending on the last member or the last element. If the last element is not given to you, we say that it is what? An infinite set. Good. Now let's proceed. So our third type, our third type is a null set. Null set. Null set is a type of set which has no member. It has no member. So if we are having this set, it's called a null set. This is a null set, or this is a null set. It means that in the set given to you, there is no member, not zero. Zero is a member or an element of a set. But this one, it doesn't have any member. For instance, when we come to intersection and union, we get to know that better. If we have A to be equal to 2, 4, 5, 6, and we have B to be equal to 7, 8, 9, 10. And they tell us to find A intersection B. In finding A intersection B means that numbers that are found here and the same time sort here. Looking at this case, 2 is here, 2 is not here. 4 is here, 4 is not here. 5 is here, 5 is not here. 6 is here, 6 is not here. So hence we say that A intersection B is equal to null sets, or this. So this is how a null set is defined. It has no member, but it cannot be zero. If it is zero, we have what another name we call it. So that leads us to what we call a unit set. A unit set. So now let's also look at a unit set. So our fourth one is unit set. Now, a unit set is a type of set which has only one member or one element. It can be 0, it can be 1, it can be 2, it can be 3, it can be 4, but it has only one member. So for instance, if we have this A to be 5, this is a unit set. It is having only one member. So depending that it's having one member or one element, we call it what? A unit set. So let's proceed with our various types of sets. So these are some of the sets that we are having. Now let's also mention another ones. We have the equivalent set. Equivalent set. Now, equivalent set is a type of set. This one is based on comparison of set A. Let's assume we have set A and set B. So the number of members in set A and the number of members in set B, the total count or the cardinality of them should be equal. So if we are having set A to be 1, 2, 3, 4, 5, 6, and we have set B to be 2, 4, 6, 8, 10, 12. So now we say that set A is equivalent to what? Set B, because it is having the same number of what? Elements based on its cardinality. So this is 1, 2, 3, 4, 5, 6. This is also 1, 2, 3, 4, 5, 6. So we say that it is what? Equivalent set. Good. Now let's also look at equal set. Equal set. So equal set. So equal set and equivalent set, we shouldn't um, be interchanging them, and it is one of the problems that most of we the students we do make. Equivalent set and equal set. Equal set means that the elements in A are the same elements in what? B. So if we have A, if we have 2, 4, 6, B2 we are having 2, 4, 6. So that's equal set. Equal set does not necessarily mean the arrangements need to be same. For instance, the first example that we had to be A equal to 2, 4, 6. We can have the B to be 6, 4, or 6, 2, 4. It's still the same, because based on the elements here, individual elements, we can have 2 here, we can have 2 here, we can have 4 here, we can have 4 here, we can have 6 here, we can have 6 here. So we say that this is what? An equal set. So this is an equal set that we are having. Now, these are the basic um, types that we can have. As we are moving on, we'll still be talking about some of the types of sets. As far as set is concerned, we'll be talking about a lot of them as we are moving on with our discussion. Continuation on this. Now we have our set also being, we can have our intersection. Intersection of a set. The intersection of a set is the number that can be found in set A and the same time set B of our set. So if a number or a member or an element in set A can the same be found in set B, we say that they are what? Intersected. For instance, if we have A, so in the kitchen, if we are having our arrangement of plates, so if we are having our arrangement of plates, we have plate 1, plate 2, plate 3, plate 4, plate 5. Now, let's assume that in the process of the arrangement, we realize that there is a knife. In place of the plate, we didn't place a plate over there, we placed a knife. Good. So let's assume the knife is the third one. So we come to our set B. In the kitchen, in that same kitchen, we are doing some arrangement too of another set of cups. Let's assume cups. So we were selecting or arranging them in order of sequence. Then we have 5, we have 6, 3, 7, 2, 7, 9, 8. In the process of arranging the cups, we realize that in the middle of it again, we have inserted a knife. And if they ask you, what is the intersection of A and B, it means that where they have met, the meeting point of A and B, that is where the knife is what? Intersected. So where the knife is intersected is what we call the intersection of A and B. So we have A intersection B, and it's always represented by this. It's always represented by this. So A intersection B is what? 3. So this is our set. Now, that is intersection. Now, let's move to the universal. Now, we have universal. Universal, it means that the number of sets, that all the sets of A and B are found in the what? In the universal set. So, the members of set A and the members of set B comprises the set of the universal. So the member of set A, the member of set B, including the intersection, forms the universal. So in simple terms, is the total of the intersection set A and set B. So that is our universal set. So if we are having our set A to be equal to 2, 4, 5, then we have our set B to be equal to 1, 2, 3. So our universal, so the universal of these, so we have our intersection. The intersection is A intersection B is what? 2. So the summation of A, B will give us the intersection. So, sorry, the universal. So the universal is going to be, is always represented by mu in the form of a populational statistic. So we have 1, we arrange them in order of what? Sequence, or in order of magnitude. 1, 2, we don't repeat. We have 3, we have 4, we have 5. So this becomes our universal set. Now, let's also look at the union. So let's look at the union. So if we are having the union set, now union and universal is more or less like same. They are very similar, very, very similar. So almost the same, because if we are having A to be apple, banana, orange, set of fruits, we have B to be Messi, Ronaldo, Neymar. And they said that we should find A union B. It means that we bring all these items together. So the union is also in the form of a populational mu. So this is the union, the symbol for the union. So this is what we are having. So we combine both set of apple and what? Set of players. So we are going to have apple, banana, orange, Messi, Ronaldo, Neymar. So this is the union. The union means bringing all the sets together, set A and set B together. So let's bring it into numerals or numbers. So we are having A. If we have set A to be multiples of 2, 2, 4, 6, 8, 10. And we have B to be counting numbers 1, 2, 3, 4, 5, 6. And I said we should find A union B. It means that we bring A and B together, but it should be in order of magnitude, and we shouldn't repeat numbers. If a number, we have a member of A that has repeated in B, we should write only 1. We shouldn't write 2. For instance, we are having 2 here, 2 here. We shouldn't write 2, 2. We should only pick one of the numbers and write. So In order of magnitude, we have 1. We write it from what? Ascending order. Then the next one is 2. The next one is 3. Then we come to 4. So 4, we have 5. We also have what? 6. So this is 6. We have 8 and 10. Mostly because it's the last number, that's why we are bringing the end to indicate that this is our last number. Now, practical example or real life example of the union is our marriage homes. So, if you get married and your wife is brought to you, now your wife is moving with all her things, her luggage, her cooking things to your place. So, it's like you are doing everything together. All of you are together at what? One spot, and you are doing everything together. So everything you are even doing it together, shared responsibility. This one do this one does this. So you are bring by the end of the day, the output, you bring the output together. For instance, you are working, your wife is working. You bring 2 CDs tomorrow, your wife brings 2 CDs. You bring 2 CDs tomorrow, your wife brings 1 CD. So this is a union. You are working together, and your resources are what? Brought together. So this is one of the practical example of what? A union in real life examples. So these are some of the basic things that we need to understand as far as set is concerned. Now, let's move on to have some problems on set. So, given A, given set A, describe your set in I. So now, this is a problem that has been given to us, that given set A to be equal to 2, 4, 6, 8, 10, and set B is 3, 6, 9, 12, 15, 18. The first problem is we should find A intersection what? B. In mathematics, anytime you are given a problem, please make sure you write your solution. Solution is very important. So you write your solution. You write the question number. So the question number is I. So we have A intersection B. So A intersection B means that what is here in set A and the same members or the same elements are in set B. So we have set A. What is here and the same time here? We have 2 here, we don't have 2 here. We have 4 here, we don't have 4 here. We have 6 here and we have 6 here. So we write 6. We have 8 here, we don't have 8 here. We have 9 here, we don't have 9 here. We have 10 here, we don't have 10 here. We have 12 here, we don't have 12 here. We have 15 here, we have 18 here, we don't have 18 here. So we have 6 as our A intersection what? B. Now we come to our II. We have A union B. A union B means we should bring A and B together, as I stated earlier. This is in terms of marriage. The A and B are moving together. So they are going to be staying in the same house, doing the same things together. So they are going to be put in the same curly bracket or the same set. So we start by arranging them in order of magnitude, in order of what? Ascending. So we start, the least element over there is what? 2, followed by 3, followed by 4, followed by 6. So 6 has repeated 2 times. You only write it once. Now we have 8, we have 9, we have 10. The next one, 12, 15, and 18. So we close our curly brackets. Now they are saying that we should describe your set in I. So this is our I. We should describe our set. So our Roman number 3, we should describe our set. Now the set, this is our set. So we say that the set is a unit set because it has only one member. Full stop. You have described your set. So anytime you are given a problem, this is how to go by the problem. This is how to go by the problem. First of all, they have given you the problem, and this is the problem. They They have given the possible things that they are looking for: A intersection B, A union B, and you should also describe your set in I. So now you write your solution. We have our A intersection B. A intersection B, what is here and the same time here, or what is in B and the same time in what? A. So when you check, we are having two. We have two here. We don't have two here. We have three here. We don't have three here in that order. But when you check, we have the number, which is what? 6. So 6 is here. 6 is in set B, and 6 is in what? Set A. So this is the set that we are having. So set A intersection B, which is what? 6. A union B. A union B, we join the sets. They have gone on a marriage agreement. We join them. So we have A union B. In order of magnitude, ascending order from smallest to what? Biggest. So the smallest number is what? Or the smallest member of the set is what? 2. Followed by what? 3. Followed by what? 4. Followed by 6. 6 has repeated twice. We write it only once. Followed by 8. Then we have 9. We have 10. We have 12. We have 15. And what? 18. And the II said we should describe our set in what? In I. So this is our I. So the set is a unit set, because it has only one member. We already stated that a unit set has only one member. Good. So let's continue. We are continuing. Please, in case of any problem, you can drop it on the comments section. Then we'll have it addressed. So this is the problem that has been solved. And in case of any addition, this is a learning process. You can have it on the comment section. Then it will be addressed. Thank you. Now let's have another problem. Add up. This is a learning environment. We can also leave it on the comment section. Then we'll correct our mistakes. We are all learning together. So let's say they have given us another set. So they can say that given P whole numbers less than 17. Then we have Q, set Q. Even numbers less than 20. Now we have R. We are having our set R. Odd numbers between let's have the odd numbers from 1. So odd numbers less than 21. So we are having this problem. So this is the problem that we are having now. And they are saying that the first question is find A, P intersection Q. Now B, P union Q. C, Q intersection R. D, we have our R, Q union R. So these are the problems that we are having. I'll first solve the first two, then the rest of the remaining two, you leave your answer at the comment section. So we have this, so we come and define, so we write our solution. So we define our point. So we have P equal to whole numbers less than 17. Whole numbers are numbers that start from 0 to infinity. So that's our whole number. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 15, and 16, because they said it should be less than 17. Then we have our Q. We have our Q to be even numbers less than 20. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. So it seems our space, please. We are cleaning the top. So now we have our R, our set R. Our set R are odd numbers. Okay, so the odd numbers, I will leave it onto the viewers so that you use that to answer the question C and D. The Roman number C and what? D. So C and D, use the odd numbers in solving that. So now we have the first one, A, which is P intersection what? Q. So what is in P and the same time in what? Q. So that is what we are looking at. So we are going to have, so we have 2 here, we have 0 here, we don't have 0 here. We have 1 here, we don't have 1 here, but we have 2 here and 2 here. So we write our first one, 2. So we have 3, we don't have 3. We have 4, we have 4 here. So we write 4. So we have 5, we don't have 5, but we have 6 here, we have 6 here. So you write 6. We have 7, we don't have 7 here. We have 8 here, and we have what? 8 here. So you write 8. We have 9 here. We don't have 9 here. We have 10 here and we have 10 here. So we write 10. We have 11 here. We don't have 11 here, but we have 12 here and we also have 12 here. So you write 12. So we have 13. 13 is not here. 14, but 14 is here. So we write 14. So we have 15. 15 is not here, but we have 16. And 16 is here. So that is our last number and what? 16, because 18 is not here. So this is our P intersection Q in the problem given to us. Now we have our B. The B is P union Q. P union Q, it means we add P and Q. The members in P, we add it to the members in what? Q, in order of magnitude. So we have P, we are having 0. In order of magnitude, 1, 2, 2. So we write one of the 2's. So we have 3, we have 4, we have 5, we have 6, we have 7, we have 8. Sorry. We have 8, we have 9. We also have 10, we have 11, we have 12. This is 12. We have 13 over there. We have 14. We have 15. 15 is here. We have 16. 16 is here. 16 is here. We don't have 17, but we have the last number to be what? 18. Any number that is not found here, you shouldn't also bring it here. Are you getting it? What? Any number that is not found there. For instance, you can see we have 15, 16, but here we have 18. So my viewers will say that because there is 18 here, 17 has to come before 18. Per the definition of the Q, this is how it's supposed to be, because 17 is not an even number. So I will leave the rest of C and D for my viewers, then they will leave their answer in the comment section. Thank you very much.